Time to zip very large, 100 grams, files. I find myself having to compress a number of very large files, 80-ish GB, and I am surprised at the lack of speed my system is exhibiting. I get about 500 MB minute conversion speed. Using top, I seem to be using a single CPU at approximately 100%. I am pretty sure it's not just disk access speed, since creating a tar file, that's how the 80 grams file was created, took just a few minutes, maybe 5 or 10, but after more than 2 hours my simple gzip command is still not done. In summary, took and LT, 5 minutes to create an 87 grams tar file. Took 2 hours and 10 minutes, creating a 55 gram zip file. My question, is this normal? Are there certain options in gzip to speed things up? Would it be faster to concatenate the commands and use tar cvfc? I saw reference to pigs, parallel implementation of gzip, but unfortunately I cannot install software on the machine I am using, so that is not an option for me. See for example this earlier question. I am intending to try some of these options myself and time them, but it is quite likely that I will not hit the magic combination of options. I am hoping that someone on this site knows the right trick to speed things up. When I have the results of other trials available I will update this question, but if anyone has a particularly good trick available, I would really appreciate it. Maybe the gzip just takes more processing time than I realized. Update. As promised, I tried the trick suggested below, changed the amount of compression, and changed the destination of the file. I got the following results for a tar that was about 4.1 GB. So yes, changing the flag from the default -6 to the fastest -1 gives me a 30% speed up, with, for my data, hardly any change to the size of the zip file. Whether I'm using the same disk or another one makes essentially no difference. I would have to run this multiple times to get any statistical significance. If anyone is interested, I generated these timing benchmarks using the following 2 scripts. And the second script, compress with. Three things to note. Using /user/bin/time rather than time, since the built-in command of bash has many fewer options than the new command. I did not bother using the format option, although that would make the log file easier to read. I used a script in a script since time seemed to operate only on the first command in a pipe sequence, so I made it look like a single command. With all this learnt, my conclusions are: speed things up with the -1 flag, accepted answer. Much more time is spent compressing the data than reading from disk. Invest in faster compression software, Pig seems like a good choice. If you have multiple files to compress you can put each zip command in its own thread and use more of the available CPU, poor man's pigs. Thanks everyone who helped me learn all this.
You can change the speed of gzip using fastbest or hash, where hash is a number between 1 and 9. 1 is fastest but less compression, 9 is slowest but more compression. By default gzip runs at level 6.
The reason tar takes so little time compared to gzip is that there's very little computational overhead in copying your files into a single file, which is what it does. Gzip, on the other hand, is actually using compression algorithms to shrink the tar file. The problem is that gzip is constrained, as you discovered, to a single thread. Enter pigs, which can use multiple threads to perform the compression. An example of how to use this would be: there is a nice succinct summary of the Use Compress Program option over on a sister site.
I seem to be using a single CPU at approximately 100%. That implies there isn't an I/O performance issue, but that the compression is only using one thread, which will be the case with gzip. If you manage to achieve the access/agreement needed to get other tools installed, then 7-zip also supports multiple threads to take advantage of multi-core CPUs, though I'm not sure if that extends to the gzip format as well as its own. If you are stuck to using just gzip for the time being and have multiple files to compress, you could try compressing them individually. That way you'll use more of that multi-core CPU by running more than one process in parallel. Be careful not to overdo it though, because as soon as you get anywhere near the capacity of your I/O subsystem, performance will drop off precipitously, to lower than if you were using one process/thread, as the latency of head movements becomes a significant bottleneck.
One can exploit the number of process available as well in pigs, which is usually faster performance, as shown in the following command. tar-cf, directory to archive, pigs-0p large number in gt, mitter.tar.gs. Example, tar-cf, patha, pigs-0p32 in gt, patha.tar.gs. This is probably faster than the method suggested in the post, as p is the number of processes one can run. In my personal experience, setting a very large value doesn't hurt performance if the directory to be archived consists of a large number of small files. Else the default value considered is 8. For large files, my recommendation would be to set this value as the total number of threads supported on the system. Example, setting a value of p equals 32 in case of a 32 CPU machine helps. 0 is meant for the fastest pigs compression, as it doesn't compress the archive and rather is focused on speed. Default value is 6 for compression.
If you want to support the channel, please subscribe.